My name is Thor Petersen and I'm a researcher at DHI. We are an independent research and consultancy organization where our objectives are to build competences and promote technological developments in areas relevant to water. Areas of expertise encompass energy, coastal and marine engineering, and part of this engagement focuses on supporting design, installation and operation of offshore wind farms. Offshore wind farms are now erected all over the world, the vast majority in the northwestern part of Europe, in countries such as Denmark, the United Kingdom, Germany, the Netherlands and Sweden. The installation of offshore wind farms increases over the coming decades, and the European goal is 120 gigawatt by the year 2030. A challenge to the industry is the complex design of the foundation structures. Installing the foundations of marine structures can be very costly. Wind turbine foundations, for example, can account for up to 30 to 40% of the total installation cost. A natural consequence of this is the need for careful planning and design involving a large number of engineering disciplines to facilitate an optimized and effective layout. The wind turbine foundations have to deal with harsh conditions at sea, such as strong tidal currents, large waves and deep waters, which complicates the matter. Well-designed marine structures require that you take Scour into account to ensure short and long-term stability. Understanding the flow structure and seabed interaction is therefore vital. I am part of a team at DHI in the Department for Ports and Offshore Technology, doing research within Scour formation around offshore structures and how the results can be used in future designs. So a big part of my daily life involves the development of new designs to mitigate or allow scour formation around the foundations of marine structures. Scour is the removal of the sediment base around the foot of the foundation structure due to increased local sediment transport, leaving a substantial hole in the seabed. From observations and deterministic designs, these holes may grow up to 1 to 2 times the foundation diameter, which in practical terms means 10 to 15 meters. Today, offshore wind turbine foundations are almost invariably protected against scour. Scour protection for one single turbine may cost up to €150,000, which adds to the high investment costs. Accurate long-term predictions on scour may reduce this cost. Using realistic mid-ocean data, sediment characteristics and structural properties as a basis, our Scour calculator integrates recent research to estimate the scour development over longer time spans. By those means, a probabilistic design can reduce the design scour depth and in turn the high investment cost of the foundation structure. The appearance of scour at the base of the foundation in combination with degradation of the seabed level, migration of large bed forms, complicates the design of unprotected foundations. The need for scour protection has been the subject of several recent investigations yielding important aspects to consider in relation to failure modes of scour protections. We are now able to help our clients reduce the cover stone size, predict the subsidence of the stone layer into the seabed, and the appearance of edge scour off the periphery of the scour protection. All in all, it adds to an optimized and cost-effective design.